you can hear something is going on.
Okay, so I think I've turned on the live stream now. So one thing actually it's setting this up. Wait a second. Okay, I think it's live now. One thing I wanted to test first is if I use this piece of technology, which is called the sticker, and I just put it over my camera. Okay, like that. Okay, right. Oh, okay. So, oh, okay. So my name is still displayed, right? And that we'll see if it's on a.
Yes, it's still displayed, but it's very small label in the bottom left corner of the tile instead of being pretty high in the middle.
Okay, so this is what Arto meant, that it's kind of so it's a sort of solution, but not a good solution, I suppose. Well, it's not a perfect solution. I think you could still see the name of the person, which was the goal, but you cannot see the big names. But I don't know. The thing about it is that I don't want to, you know, when I start searching for these solutions, right? Yesterday, I just completely people do all sorts of complicated stuff with this. Like they use the screen capture software, they use two Zoom sessions, they combine things together. I said, okay, you know, I need to learn these things step by step. You know, you can't just, maybe eventually we will get there. We will get to the setup we want. But at the moment, I will recommend if people want to see their names on a live stream, but they don't want to show the camera, they should use the stickers. Okay, so I didn't figure out the topic today, and I think there was one person who really wanted to join, Leo wanted to join, but I'm not sure if he's available at the moment. Let's check. Where is he going? So, but that's why I didn't specify the. Oh, I think is online on Discord. I just ping him because yeah. So I thought one of the things we could do. Hi, Jochen. Good to see you again. You know that this is live streamed, right? Hello, Jochen. You know this is live stream, right? Okay. So I was just saying that if you don't want you to be seen, but you still want your name to be visible in the live stream, you have to use something like a sticker over the camera or something. Because we haven't figured out a more high-tech solution to this yet. So Leo is coming. And as I said, I didn't define the topic for today, but I wanted to not do one thing that I was doing for previous sessions. I actually looked at them and I'm dominating the conversation. So I wanted to start with asking Leo how he's progressing, because he just joined the team recently, and I gave him the relatively difficult task to do, and so I wanted to hear the feedback, how it's going, and then we could just go around and see if people wanted to say something or talk about something else. But mostly we're just simply testing this new format with the so now Andrea is putting his thumb on the
Yes, I thought you do not really need any kind of equipment. You can use
you can use the thumb, but the problem is that if you do it for a very long time, you're going to get yourself some sort of trigger points in the shoulder. Especially in our age, right? It's
it's my age, not yours age.
No, even in my age, it's already, you know, if you do something like this for 15 minutes, it will show. I mean, my muscles are not as young as 20 years ago.
Yes.
Hi, Leo.
Imagine mine.
Hi, Leo. So we didn't define so by the way, this is a live stream, right? You're aware of this? Okay.
Hi, Leo.
Hi, Leo. So if you don't want yourself to be seen on the live stream, but you want your name to be seen, you can use the sticker because we haven't figured out the more high-tech solution for this. So I wanted to start, I wanted to not dominate the conversation as I was last times. I wanted to start with you, Leo, and tell us about your experience so far with how you is going. How is your current task is progressing for the ones that we discussed in one of the previous live streams?
Oh, okay. Can you hear me? Just confirming.
Yes, it's good. Yeah.
Okay. So good day. Well, how it's been going so far? I would say it's been great. It's been great. It's been a huge learning curve for me, a very steep one, but I've been keeping up. So I think I've been keeping up. The current task at hand has been challenging, quite a bit challenging, and I think has been challenging because mainly of the lack of documentation. So that was why I said earlier on I was going to volunteer to make a documentation if I get past this hurdle. So because the code base is kind of large, so it's taking me time to like understand, oh, what is this doing? What is that doing? And aside that, other than the fact that the code was pretty well written, that helped a lot. So that's really been it for me.
And what is your so current thinking? Are you stuck at the moment, or do you have everything you need to go for this particular task?
Okay, well, I think I would be stuck because I was stuck before. I had some errors and all, and I ended up changing a lot of things, even stuff I wasn't supposed to change, and I like ended up breaking my code, so I had to like go back and revert commits and all that. So I'm kind of like starting the whole process again. And so maybe when I get to a hurdle, I'll reach out.
Okay,
for now,
cool.
I'm fine.
But I think, yeah, even if you actually started to change the code, you're not supposed to. It's a really good that you figured it out, realized it. So that's a good kind of learning practice, is where you get to the weeds. But if you actually figure out yourself that you're in the weeds, it's a really good sign you're learning. And how is your understanding of the because you told me that it was kind of a bit hard to understand, like what is the transaction pool, how the transactions flow in through this thing, like what are the different repositories. Do you kind of get it a bit better now?
Yes, I do. As I told you, I kind of figured out one of the reasons I've been slacking was because I lack understanding in the whole blockchain realm. I couldn't understand what the TX pool was, the main pool, and all that. But thanks to some of the README files I found on the Aragon repo, I've been able to get conversant with a lot of those stuff. And also I saw the wiki page, that helped a lot. I just stumbled upon it. So
maybe what we could do now is that to just kind of fix it up a little bit, and then maybe it will be also useful for others. Can you just tell us what do you understand about the transaction pool and the transactions? And we're going to just listen, and afterwards we can tell you whether what can we bring further to your understanding.
Okay. Really, I see the transaction pool as this gathering of transactions that haven't been like approved by the collective peers, right? Before they get to a block or being processed to a block that has to be executed, as Andrea said. That's what I see this transaction pool as. And I see transactions as this little doings of different peers trying to like maybe buy stuff or purchase stuff, and then it has to get approved by like different other peers on the network. So yeah, and yeah, that's pretty much what I think about transaction pool and transactions.
But when you say that approved by the peers, what do you mean?
I'm thinking of it in terms of consensus, like maybe everyone on the network has to like say, oh yeah, we understand that you want to do this, and it applies to our blocks, like it's conversant with our blocks, we have the same kind of data.
Okay, so but what is your view about this consensus? Do you view the consensus in Ethereum as essentially peers in the network approving the transactions? Is this how you see it at the moment?
Kind of. I don't mean they have to manually approve it, but like
yeah, I mean,
I think it has to be like in sync with their own like inputs or something like that.
Okay, so I Yeah, I think we should talk about consensus then. Maybe Andrea, who could be a good person to explain what is the consensus in Ethereum, and who actually has the power to decide which transactions do get into the blocks and which do not.
Oh, okay. I'll reach out to him later.
No, Andrea can explain right now. So I think we'll just use the time right now.
Well, the first thing that I think is important to underline is that clients do not find a consensus amongst each other. Each client implements a set of rules which are defined in the Ethereum protocol, which define exactly how transactions and everything that goes into the blockchain must be validated on a semantic perspective, on their syntax and on their status. Okay, so basically the process is that when a new transaction, which might be a transfer of tokens from A to B, or an account trying to interact with a smart contract or anything else which wants to be inserted into the blockchain, gets received by the first peer the wallet is connected to, and the tool that is issuing the transaction sends this transaction to the first peer. This peer collects this transaction inside the mempool. It firstly validates on a strictly syntactic aspect.
One second. So just to clarify, mempool is basically the same as transaction pool in this context, right?
Yes. Sorry, I often use the term memory pool because it's the same concept that is implemented in Bitcoin. It was originally called mempool because it resides in volatile memory, in RAM memory, generally speaking. This is what happens in Bitcoin. For several other reasons, you can find also in Aragon, the transaction pool is persisted into the database, so the term mempool doesn't apply anymore, but eventually it's the same concept. So we call mempool or transaction pool in the very same way, okay? So just imagine that is something that can be discarded, which is not persisted in, how can I say it? Basically, what's not persisted in the blockchain itself, doesn't exist really in complete yet, okay? But it's something that is willing to be inserted into the blockchain, okay? So the first step is for transactions to get accepted in the blockchain, in the memory pool, in the transaction pool, where it receives a first validation, where the rules check that all the fields of the transaction are properly valued, that the encoding is correct, that the fields that might have variadic length do not exceed the limits, so on and so forth. Okay. When this first
is this the same? Is this the same place where the account has to be checked if it has enough money to pay for the gas fee?
No, this is a syntactic check. Okay. In the mempool, you do not know yet, even if you can have an estimate, you do not know yet exactly which is the cost of the transaction, the overall cost of the transaction. Okay. So When the transaction gets into the mempool of the receiving node via the P2P protocol spreads this transaction to all the connected peers. So also other nodes have a proper view of what is willing to be inserted into the blockchain. At this point, every single node tries to create their own block templates. Okay, a block template is a tentative block which try to ensemble the maximum number of transactions that can fit into the block. And by can fit into the block, I mean that do not exceed the gas limit that the transaction are going to spend. And for mining purposes, as mining is right now based on proof of work, they also try to maximize the profit for the miner. Okay, so trying to basically the rule of thumb, pick first the transactions that are willing to pay more. Okay, this is a very basic.
But you did, Andrea, you skipped the bit that Leo was asking about at which point we check that the sending account has enough ETH to pay for some gas or things like this.
Yes, we check it before the mining phase. When we try to create the block template, okay, and we estimate the interactions this transaction has with either, if it's a simple transaction, that we have a very simple operation of transfer. If instead it's a transaction which interacts with a smart contract, we have to analyze the smart contract code, read the operations that the smart contract implements in interaction with that address, compute the cost for each operation, try to figure out which will be also the cost of storage of the whole transaction, compute which will be the cost for that transaction to be executed, and then we check that that cost is coverable by the actual funds that are accounted for that specific issuer willing to insert that transaction on behalf of the state that we already have from previous blocks and previous transactions.
This is Andrea, this is correct, but that's actually, I think it's still the slightly different check. So what you're talking about is basically running the transaction and figuring out its exact cost.
Yeah.
But there is another thing which exists for the purpose of what they call DOS protection, and so what's it called, the amplification attack. So the way that amplification attack would work is that, let's say that I create a transaction that that is sent but is signed, let's say digitally signed by the private key, which corresponds to an account which has no ether or very little ether to pay for the gas. And I just keep sending those, I could create a million of those things and I can send them off, and it doesn't cost me a lot to send them off, but all these transactions, they would have to fly through the network, have to be checked, and eventually, if they are all propagated, if they all let through, eventually what will happen is that if the miner who is eventually going to have to collect those transactions and put them in a block, it will be bombarded by all these useless transactions that nobody is going to pay for. So that's why we introduced some simple checks, which is much simpler than what you described, like when you don't actually have to execute the whole transaction, but you can have a rough idea whether this transaction will actually be paid for. So, and there are two rules there. First of all, if you look at so each transaction has the two fields that matter. I mean, at the moment, there's more like 4 fields or 5. But previously, before the London upgrade, there were only two fields that we were looking at. Is the gas limit of the transaction. It means that how much maximum gas this transaction is allowed to buy, to purchase from and also the gas price. So because what happens is that when we execute transaction, what the first thing we do is basically get it to purchase the gas, because as you might know, there's ether and there's the gas, right? There's two different units. And you basically, what you do is that when your transaction is executed in the block, it uses the ether on your account to purchase the gas. Then this gas is used to execute the transaction. And if something is left and it's allowed to be refunded, it kind of goes back into your account. And that's actually, it is exactly how this works, because if you're in the middle of your executing of a transaction, you ask the Ethereum, the EVM, what is my current balance, right? What it will give you is actually, it will give you the balance where the whole gas is purchased. It's basically, it means that if you're in the middle of transaction, you don't see the refund yet. But once the transaction is finished, the refund is applied and your balance is kind of increased again. So what we're using this logic to filter out those potentially spammy transactions. So when we see the transaction and say, okay, so this transaction has a gas limit of million, for example, million gas, right? And it says that it's going to pay, let's say, 20 giga Wei, or whatever, giga is 20 billion Wei per 1 unit of gas, right? Which basically works out, it's 0.02 or whatever, 0.02002 ether. So you get the point. Yeah. And then we say, okay, does this account actually has that much ether so that it will be able to pay for it? If yes, then we say, okay, well, that is potentially viable transaction and we can let it through. However, if we see that this account doesn't have that much money, so this is now pretty much unviable transaction. There's no point propagating it and actually burdening the miners with it if we can just stop it. So in this case, if somebody tries to spam the network, it will be very difficult for them to do so because there is no amplification. So they will just give it to the peer, and their peer is going to say, no, that's not viable. I'm not going to send it further. And then basically this attack stops in its track. There is no, but if you didn't check, essentially what you can do, you can use the entire network as amplification vector. Is that you basically give this transaction, unviable transaction, to everybody, it gets propagated, and then basically it's the whole network starts bombarding the miner on your behalf. So in order to prevent this amplification attacks, we have this little rules about non-gaps, about the basically there's two rules about non-gaps and the account balance.
Oh, okay.
Yeah. But you also mentioned some other thing, Leo, that you said in your description that the transactions are purchasing something, right?
Well, what I meant was, okay, to initialize the transaction, it has to be for a purpose, right? So maybe we're trying to execute a smart contract, or you're trying to buy an NFT or something. So that's what I mean by purchasing.
Oh, but nobody actually checks that. What is your intent of this transaction? The system basically doesn't have any means to ask you. So why are you doing this transaction? That's the whole point of the permissionless system.
Yeah,
nobody asks the question. Nobody asks the question.
Yeah. The basic thing is that the whole blockchain is a big accounting ledger, right? Okay. So where tokens are transferred from address to address or interact with contracts, which have their own balances also. So what is the transfer of ownership of services and goods on behalf of the transactions which are recorded into the blockchain is completely out of the scope. So we don't know what you are buying, if you're buying a service, a good, or a ticket for the movies or anything else. It doesn't matter.
Or perhaps you're not buying anything. You're just getting scammed by somebody.
Or you're getting scammed. We can't check the true intentions of the transaction. What we can check is that the transaction can pass through or have to be rejected due to several problems. Mismatching nonsense, not enough funds, there are a lot of reasons.
If it's above the gas limits.
Sorry?
Sorry? He said something about above the gas limits, but then we lost him, I think. We lost Leo.
It seems like he's frozen.
Yeah, he's frozen, but I hope he'll come back. Okay.
Sorry, Leo, we got you frozen for a few seconds.
Yeah, we didn't hear what you said for last like 30 seconds or something.
Yeah, you were saying there are reasons for the transaction to get rejected. I was saying, I gave an example. I said when the transaction gas price is above the gas limits.
No. The gas price is cannot be above the limits. Sorry, Andrea, explain. Yeah.
No, the gas limits. You can pay whatever you want. Okay, for a transaction. It's obvious that anybody try to pay the less possible for their transactions. Okay.
Okay.
What is also obvious due to the mining actually enforcing the security on the network is that as miners try to maximize their profits, okay, they try to give an advantage to transactions willing to pay more to be inserted as soon as possible in the very next block. The less you pay, the more likely you will have to wait a little bit more to be inserted in the block. Okay.
Oh, I get.
But basically you can pay whatever you want. We had great examples where there were blatantly mistaken transactions where the value being transferred was wrongly accounted in the transaction fee paying, and we had transactions that were transferring a few dollars of value, paying fee of a couple of $1 million. Okay, so there is no limit on the fee you're willing to pay, and the miners are more than happy to mine those kind of transactions.
No, but to be fair, in this particular cases, they usually return this money because it's obvious mistake.
Yes, right? But I think in the very last example that was from Ethereum, they kept the fees because they were not contacted back by the issuer.
Right, because the transaction sender did not ask to return the funds, and that's why they didn't.
Yes.
Because that's another interesting issue here is in these cryptocurrencies is that you cannot refuse in most systems. You cannot refuse receipt of something.
Yeah.
And that's why there's things like airdrops. People can airdrop on your account without you knowing, and you don't necessarily aware of what you're receiving. And sometimes you're receiving something which is of great value, but you had no idea. And you had a choice of like either try to return it or just pretend that you never saw it, this thing. Or I mean, for most of the airdrops, for example, I completely ignore them because, a lot of times they're just a trap because they try to, there's lots of different schemes. But I wanted to also clarify a bit. About because I still kind of I think Leo is frozen again, right?
Yes, I was trying to get to the concept of gas limit.
Oh, okay. But I actually wanted to try to the concept of who decides which transaction to put in a block, and I wanted to use the concept of auction and auctioneer and like a leader, because basically in the actual fact, there's at any point of time, there's only one entity which decides which transaction go into the block. which is basically, and then it's I think yeah, it's counterintuitive, but this is how it happens, right?
So why do you mean what do you mean by a single entity?
Well, I mean the mining pool. The
mining pool is a node. Okay, it's it's a particular node with a very heavy hash rate. Okay,
yes.
But it's basically a node which implement their own rules for reassembling block.
Okay, Leo. Now we have two of you. Okay, so I wonder whether I should remove one of you, which is frozen, or not. Oh no, now one is gone. Yeah, now it's only one. Okay, but Leo, do you still? So we're going to about to expand on the concept of. Do you still understand who kind of decides what? Because you use the word approve, the peers approve the transactions, but who decides which transaction get into the block or not? Do you understand this concept?
Yes, I think.
Can you explain us what you understand?
Yeah, I think Andre said there are sets of rules which have to, and these rules have to be followed. So I'm guessing it's whatever implementation of the network of peers that decide what or if these transactions get approved.
No, that's not the case. Okay, I think we need to clarify this.
No.
Okay.
We have passed the first phase when the transaction is inserted into the mempool, in the transaction pool, sorry, and shared, and the receiving node spreads this newly arrived transaction to all the peers, and all the connected peers do the same with all the peers. So basically, in a matter of minutes, all the peers of the network should have the same image of the transaction pool, the same view of the transaction pool. At this very moment, every node which is configured to mine blocks uses the memory, the transaction pool, as the source from which to collect different combinations of transactions that maximize their profit and can validly fit into the next block, which will be appended to the chain. Okay? And how do they do that? Basically, a mining node decides to pick the transactions who pay more, because the miners, receive as a reward for mining a block not only the issuance that is set in the protocol rules, which at this very moment is 2 Ether per block, but they also receive a part of the transaction fees that the issuers are willing to pay for that transaction being executed. Okay, so basically they try to build up the richest pie possible and try to eat it. Okay. So they build up a block template or a block candidate, if you want to call it so. And this block candidate produces a hash, or better say, the header of this block produces a hash, which goes through the proof of work algorithm. The proof of work algorithm is a linear search of a nonce, which has nothing to do with the nonce of the transactions, which aims to provide a result for the algorithm, which is a hash that has a value.
Hello, sorry, I think I lost you.
Hello, can you hear us?
I think he's frozen again. But Andrea, maybe we could explain the mechanism on a slightly higher level. For example, I found it in the past. It's good to explain why proof of work is actually called proof of work. Why is it? What is it proven, and who is it proven to? And and in this context, you know, the thing is that if the proof of work did not exist, you know, there would be a lot of people who would want to create a new block because they get reward and then they get transaction fees. And imagine there will be thousands of people across the world wanting to produce a block, right?
Yeah.
But how are you going to pick which one has the honor has the privilege to actually do that, to be considered out of these 10,000 different blocks that people want to produce? Like, how would you pick the one, right?
The winner is the one which produces a block which has the highest difficulty.
Right.
Sorry, the highest what?
So maybe
difficulty.
We've lost you a few seconds ago. I do not know how much you get of my previous.
I head on to the point you said, the proof of work algorithm. You were trying to explain how that works.
Okay.
Maybe you could, Andrea, maybe you can work backwards from the concept of difficulty, so that because now we kind of latched on, okay, we choose out of all these people who want to make blocks, the one which makes of the highest difficulty. Maybe you can explain what difficulty is and then go backwards from there.
Okay, let's get to the concept of difficulty. You might have heard several times about difficulty in mining on the proof of chain works on the proof of work chains, and particularly on Ethereum. What is the difficulty? The difficulty is a tricky concept because it balances several things. First of all, when you mine, when you want to mine a block, as you have a reward for that, the work you are trying to do, we've lost. Leo, are you still there?
Just keep losing him, unfortunately. Okay, right. I think he's coming back again. Yeah, we keep losing you, unfortunately.
Sorry, my Zoom app keeps crashing. I don't know why.
So where did you lose us, Leo? What was he saying? Was Andrea saying?
Yeah, Andrea was talking about the proof of work algorithm. That's why I lost you.
Okay. Well, he started to explain difficulty.
Okay.
Oh yes, I lost him up until the point where you mentioned difficulty, and then he started to explain it, and I lost him again.
Can you tell me what you know about difficulty in mining?
Not a lot. I assume is the how hard it is to like mine a block, I guess.
Right.
By how hard you mean what exactly?
I really don't know.
It's how much energy essentially you spend, right, Andrea?
Yeah.
Okay. You said how much energy?
Yes, how much eventually it translates to how much energy can you spend per unit of time trying to find this particular block, right? Andrea could explain.
Yes.
Okay.
The difficulty, as we will see in a few minutes, is regulates most of the life of proof of work chains. The first regulation is, as Alexei mentioned earlier, as the miner gets a reward for mining the block, many miners want to participate to the party, and obviously, as there can only be one canonical block, okay, for every single height, we can have only one block 1 million, only one block 1 million one, only one block 1 million two, and so on. As different nodes try to mine their own version of block n+1, you have to come to a point where the proposal of a new mined block have to elect only one winner. And the one winner is is the one which have produced the higher effort, so have produced the block with the highest difficulty amongst all the others.
Okay.
Okay. But also difficulty has another meaning, and it is very important in blockchains where the block timing is constant. Because difficulty has more power and more hash rate, and by consequence, more power, more energy, more kilowatts are spent on the chain to solve this math puzzle, which is the proof of work, the more likely you will find new miners finding new blocks at a higher and higher and higher pace, which is not acceptable due to economical issues. Because if we produce blocks at a very fast pace, keeping constant the issuance, we increase inflation of the coin. And increasing inflation means that we decrease value. Okay. So
well, actually, sorry, I'm interjecting. This is not the only reason why.
Not the only one. Right?
I think there's also a reason if the interval between the blocks is too small, then they won't, and because there is a certain latency of block coming from one node to another, it will be very difficult for people to come to the agreement what is the actual current block right now, because it's going to be just a wash with all different blocks. There needs to be some sort of settlement time where everybody saw this block and they said, okay, fine, we agree. We all kind of agree that this is the last block, right?
Yes, because we have to step a little back. When a block is mined, or better say, when a node finds a solution, or better say, finds the proper nonce that solves the proof of work puzzle for the block he's trying to mine, that doesn't mean that that block is immediately chained, append to the other blocks. This block is chained as a proposal to other nodes, which have a time to decide if that block provides the highest difficulty, or there is another winning block from another node. And this phase is the phase which determines which block gets the canonical one into the chain, and other might be valid blocks may become uncles of that block. And so the network has the time to settle a final decision on whether which block has to be permanently inserted into the chain. Okay?
Okay.
So, as I mentioned earlier, as the value of Ether increases and increases, more hash rate, more power is getting into the mining industry, and as more power gets in there, more likely we are finding new blocks at the higher pace. And this has consequences on the timing of the times node have to deal with the settlement of the canonical part of the chain, as it has also economical and financial effects. To counterbalance all those and to keep the interval amongst blocks as constant and as possible, nodes implement a rule which is defined in the protocol, which says that if the timing between this block and the next one is less than the average, then the difficulty increases. If it's more than the average, then the difficulty slightly decreases. Okay.
Okay.
On top of that, there are also other concepts that you might have heard of, which is one of them is the ice age, which is a further corrector of the difficulty, generally in the direction up, which has the purpose to further increase the difficulty, pushing the interval amongst blocks even more apart. And this one and this ice age or difficulty bomb will be diffused in the next hard fork in December, if I'm not
I just actually, you know, when you said the word ice age, I just thought about because usually when I try to explain this adaptive difficulty to people, you know, you usually introduce the concept of feedback loops, systems with a feedback loop. And imagine that you're going into the shower and you have this control where you basically, if you turn clockwise, the shower gets hotter, and if you turn counterclockwise, it gets colder.
Yeah.
And you have your comfortable temperature, and you try to, it's a new shower you haven't used before, like you go into the hotel, you try to find out like, what's the, you know, how should I get this? And then it has a certain delay. So if you pour, you know, you said, oh, it's too hot, then I just need to pull back and so forth. So it's sort of what the blockchain tries to do, but instead of getting to the comfortable temperature, it tries to get to the comfortable block interval. And if the blocks are becoming too close to each other, means that the water is too hot, it has to slow it down a little bit, pull this way. And if it's too cold, which means that the blocks are too rare, it has to turn again. But what the ice age does, it kind of breaks this mechanism. It has the water gets colder, the water in a tap gets colder and colder, so that eventually whatever you do, you will not be able to get yourself a comfortable temperature, and the blocks will become longer, and eventually you freeze and the whole blockchain stops.
Yes, yes. There's a rationale for that, because the difficulty bomb is not something that is the outcome of some sort of bug. It has been put there on purpose due to the roadmap of Ethereum migrating to proof of stake instead of proof of work, as a disincentive for miners to acquire new equipment and spend more energy to invest on the blockchain, and progressively move them to another kind of revenue, which is the passive income, passive sort of income, which comes from the proof of stake mining, which is still a mining, but with different rules. And
but you know what, I think we probably should not go into
too far.
Difficulty bomb is probably too far.
Okay.
So I wanted to ask Leo again. Now, can you tell us, do you understand now how the decision is made about which transaction get into the block?
Yeah, it's basically the proof of work, where the nodes in the network have to like solve this like complex problem, this mining. So in order to prove that this transaction is legit, or can be moved into the block.
It's the proof of work is not attached to a transaction, it's attached to a block. And the block is essentially a collection of transactions. It's like a package, right?
Yeah, so like what I meant was, when this transaction is attached, you have to like recompute all the former transactions in the same block and verify that this transaction is part of it, I guess.
Okay. So not really. The mining node, the mining node packages a block. Okay. At that very moment, the mining node has already decided which are the transactions that will go into the block. When the package is complete, you have to seal it, okay? To prove to the other nodes that enough work has been done on that block to seal it, okay? And to seal it, you have to spend some amount of energy, okay? The block which has spent the higher amount of energy wins, okay? At that moment, the block and all its content, so all the transactions that the block carries with it, okay, get inserted into the chain. And after that, it has been inserted into the chain, the block is executed, okay? The block is executed, what does it mean? That every single transaction within the block is executed, whether it is a simple transfer from A to B or an interaction with a smart contract, okay? The result of that this execution updates the issuer account state. If, for instance, I have a transaction with transfer 1 Ether from me to you, after the execution, my account state records that I have 1 less Ether while you have 1 more. Okay?
Okay.
Well, yeah, I think it's also, sorry for interjecting again, as we get to the state, I think it's also quite interesting to look at Bitcoin first and compare it with Ethereum in this case, because there, for example, what Andrea just said, that when you package the block, this is where you decide which transaction go in there, in which order, which also important. The order is important. After that, you can mine it and then you can execute it. This is actually true for Bitcoin, but it's probably not quite true for Ethereum, because in Ethereum, there's a bit of a loop around, because you have to execute transaction in order to figure out one of the hashes, right? The state root hash. But in Bitcoin, it is true that you can decide the order of transactions, you can package the block, and then you can go ahead and mine it. As long as the transactions are valid.
It's even a little bit different because in Bitcoin, what you basically send out to miners, which are not nodes, to the hashing machines, is the whole package of all the transactions, and you leave them the freedom to create the root hash for that block.
I thought it was very similar to Ethereum, no?
No, because in Ethereum, the miners do not have any knowledge of the transaction they're mining, because they only receive the hash of the block header and nothing else.
Well, I'm not sure about this. But when we talk about the state, one of the reasons I think it's good to start with Bitcoin is that in a Bitcoin you can imagine the state as being like a spreadsheet, where with the 2 columns, and in first column you have all the basically public keys of the account owners, and in the second column you have basically the Bitcoin balances. And
this in Bitcoin, the transactions are pre-validated on their balances, and then inserted in the candidate block.
So it's more complicated than this, but it's a simplistic presentation of the state.
I have a couple of nice PowerPoint files describing the difference in the mining part, or better, in the hashing part of the mining phase. The differences amongst Bitcoin and
okay. I want to return back to Leo. Leo, can you just explain us again what you understood about? I mean, because I'm just trying to understand whether we're confusing you further or we actually clarifying anything. Again, the same question. How does the order of transaction get decided?
Okay, hold on. So So I'm going to do this, yes. I'm going to talk about going to start from where the transaction gets like requested to like come in. So it comes in, right? It comes in into the pool, right? And then there's this template or a block representing this transaction that is created. And then this template is like sent to everyone in the network, right? And then other nodes.
No. The transactions go around network by themselves without the template. So they travel alone. They're not packaged. They all travel alone, and they only get packaged just before the mining.
Okay, so when they travel alone and they make copies, like their copy is sent to other nodes of the network, right? Of this transaction.
Yes.
So so this template gets built after these copies have been sent, or
So on the certain, because basically the miners, they regularly create these templates. They grab whatever they've got in their pool, because the pool can have like 10,000, 20,000 different transactions. They just pick and choose the one that they want, and then they make a template. But they constantly receiving more and more. The transaction keep on coming. Like there are some transactions that live on the pool for hours, some of them for days, but some of them, the ones where the sender pays more, they get snapped up quickly. They just picked out first, and this is how you can get your transaction to mine first. You just pay more for it, and then you will know that the miners will pick it up. But if you want to pay cheaper, you can still do that, but you might need to wait for So eventually, maybe if there's no more competing transaction, it will be picked. But but they do travel alone. Okay, go ahead.
Okay, so at what point do the other nodes validate this particular transaction? Like if I've sent copies of this transaction, sorry, if these copies have been sent to other nodes on the network, at what point do these other nodes validate this particular transaction?
Okay, so it depends on what sort of validations you mean. So as Andrea said, there is syntactic validation, which happens always when you receive the transaction. If it's not valid, you don't consider it. Then there's a validation which prevents the amplification attack, which basically checks whether this transaction is possibly viable or not. And this validation happens before you send it to your peers to make sure that the unviable transactions do not spread around and do not use as amplification vector.
Okay.
But then there is more validation. I mean, there's more validation. For example, what could it be? I mean, I think by this point the transaction is pretty much valid. Do you think?
Yes, basically, we validate it has the proper nonce, and it has enough funds to pay for the max gas.
Yeah. Because basically in Ethereum, even if transaction fails to do what the sender intended, it's still included. So for example, if you had the computation and you did not estimate this computation will take that much gas, for example, you said, well, I only prepared to pay for, let's say, for 100,000 gas, but it turned out that transaction needed 200,000 gas. What will actually happen is that it will execute halfway through. It will figure out, oh, I'm out of gas. It will fail, which means that whatever you wanted it to do is not going to be done, but it will still be recorded. It will still be included in the block. It will just simply burn your money, right? And so the next time you'll think, oh, I need to give it more gas, this kind of, but once the transaction is syntactically valid, once it's got correct nonce and everything, and you got enough money to pay, that's it. After this, it could be included already. And in the documentation that you might see in our transaction pool design, it's a green pool. The green pool is a transaction which could be readily included into the block.
Oh, okay. So it's after this validation that this transaction now has, where the other nodes receive like a reward for the proof of work, and then it gets added to the block, right?
Well, they try to add it to the block. So the reward is not received yet. So the way the reward is received is actually, like if you are the miner, imagine, right?
Okay.
And where you try to create this block, you know that it is allowed for you to credit yourself to Ether. first of all, as the miner. And so, but you need to specify your address as the miner, which is called Coinbase. So obviously you're going to put your address, not Andrea's address, because you can, of course, put Andrea's address there, which means you're going to spend all that energy, but he's going to get the reward, right? So obviously you're going to put your address. And so if we're all mining, all 6 of us, we're all going to put different addresses there, right? And we might also put different transactions in our blocks, right? And which means we'll have 6 different versions of the block, right? And then we all 6 of us will spend energy trying to seal this block, as Andrea explained, try to solve this puzzle. We obviously going to have a different solutions.
And then I need to clarify a bit another thing. We have to make a clear distinctions amongst mining nodes and miners.
Right.
Miners are the people running those power-hungry machines, which might be GPUs, ASICs, CPUs, whatever. Which does a computation which is not difficult, rather is hard. Which is too complex, 2 different concepts. It's not difficult to guess to solve the puzzle, but there are so many combinations that you have to try. Obviously, the quicker you are in doing those tries, the more likely you win the competition. It's a constant race amongst miners. These are miners. Miners per se do not have a single clue about what they are mining, or what they are hashing.
This is what usually happens, but in theory they can have a clue, right?
In theory they can, but as you may have noticed on recent news about Ethereum hash rate, which is shared by a quote of over 50% by only 2 pools, you quickly realize that these 2 pools have a lot of customers, a lot of hashing machines distributed worldwide, which do not have a single clue of what they are doing. Basically, they know what they are doing, but they do not know what is the context for what they are doing. They receive a hash, which is 256 bits long, and they do apply on top of that a nonce and an algorithm.
So I think this is actually quite useful, but I still think we could unpack this later.
Yes, the mining node instead is a node like Aragon, which tries to create the block, picking up its own transactions from the mempool, from the transaction pool, tries to seal it, and tries to spread it as sealed to all other peers. Saying, I have found a solution. Maybe another node says, I have a solution too for block 10. Who wins? Mine is have a higher difficulty. You win. Mine becomes an uncle. The mining node which wins in its configuration has configured a Coinbase address, which is the address which receives the issuance for the new, basically the new minted ether for each new created block.
Okay, so I think, but for the purpose of this question, I think it's okay to say the miner is somebody who has the ability to solve this puzzle, right? And of course, in the beginning, when Ethereum just launched, or maybe when Bitcoin just launched, so when Bitcoin first launched in 2009, you can actually solve this puzzle with your computer, with the CPU. And that's why in the Bitcoin white paper, they say one CPU, one vote. By voting, you mean like whoever gets the more power, you can actually parallelize this puzzle, the more computers you have, the quicker you can find the solution, right? Because basically you're searching the space of numbers and you're trying to find which number fits. And obviously, if you hire more computers, you can actually make the search quicker. And the same with Ethereum. I remember when Ethereum first started, 2005, I could use my computer's GPU to be able to mine blocks. And I mined 11 blocks within the first few days. And now it's completely impossible for me, because in order to mine 11 blocks within the next few days, I would need to, even if I fill this whole room with equipment, it's not going to be enough.
No.
I will only get a tiny fraction of those 11 blocks because the race is going on, right?
So is it now harder because more people have joined the network and they
because the difficulty has
spread?
Well, because the difficulty has been, do you remember we talked about adaptive difficulty? The more people are in the game, the more energy they throw in it, the more difficult it becomes. So basically 1 unit of energy buys less and less ETH. And as Andrea mentioned, that if the price of ETH keeps growing, that's okay, because then you need to buy your energy. You spend your energy to mine ETH, but as long as the price of ETH goes up, it looks like you're making money. But when the price of ETH starts going down, then of course, I mean, the difficulty will have to correct downwards. But there could be other issues there. But yeah, but for the purpose of understanding how the transaction get into the block, we don't really need to know what Andrea was referring to is how the industry has grown from me being able to mine 11 blocks on my machine in 2015 to basically completely professionalized and separated duties, and some people running the node which compose the blocks, other people distribute the computation of the compute puzzle, and they'll communicate with each other. So the ones that produce the blocks, they're called pools, right? Mining pools.
Oh, okay.
Yeah, and the ones that actually make these puzzle solutions, they're called miners, or they actually run these power hungry GPUs. But it's kind of the detail which is super important to know, but not to answer this particular question. So now try again to describe us how this works.
Okay, so should I start again from when the transaction joined? Okay, so the transaction joins, like it comes in, and then the transaction is sent to like multiple nodes on the network. Copies are made, and then those nodes validate this transaction through the syntax validation, the amplifier check, and the other one. And then before the reward is given, all these miners or mining nodes have to like make all these computations on it, and whoever provides or puts in the most energy into mining the node gets the reward from the proof of work, which after this is then the template of the block is then created and then added to the existing blockchain.
I mean, there is no specific order in which these things happen. When you say that first the reward is given and then template is created, it's not like how there's no specific order. The thing,
there is specific order.
Well, there is, but it's not this order.
Yes, it's exactly the reverse. First, you create the block. Then you spend the energy to seal it or to solve the proof of work puzzle. When the block is solved, is sealed, and is accepted by the chain as canonical, then the execution of the block gives the miner the reward it deserves. This is the order.
Yeah, so you actually, it is perfectly possible for you to spend all this energy but not getting paid, right?
Okay, so but you may have missed a step. You say transactions come in, and then they are spread to other nodes which do verify the transaction. How do you imagine that transactions come in? Come in from where?
Okay, I assumed when maybe a party or an account tries to like executes, let's say for instance, a smart contracts, he or she has to pay like a transaction fee for this particular transaction to be recognized.
I'm talking a little bit over. What would you use if you want to create a transaction on the blockchain? Which tool, which software, which whatever you create, would you use for it?
I really don't have an idea.
Okay, you create the most commonly used tools are the wallets. Okay, you may have heard of many names. You may have heard of MetaMask. You may have heard of Exodus. You may have heard that there are Jax and so on. All these tools are connected to a node. Okay. When you submit a transaction, you are talking directly to a node. Okay. Then that node firstly verifies the transaction, the syntactic part, and the anti-spam protection of the transaction before it gets propagated to other peers.
Oh, okay.
Okay. And other peers do the very same task. As it's a peer-to-peer network, the basic concept is that each node doesn't have to trust anything from other peers without prior checking all the information, except what is already in the chain, but even in that case, with the degree of salt.
Well, actually, what I was going to say...
Because actually, you should verify every single transaction written in the blockchain from the very beginning. Well, and that is, but there are some cases when the tampering with ancient data on the blockchain would require such a power of computation to rewrite all the subsequent states, because it's called blockchain because each block is chained to its ancestor. So the seal of this block is built on top of the data of this block plus a bit of data from the ancestor block.
I actually have an idea, so that we maybe in terms of time we might want to get it to the finish, but in order for you not to get a bit, because I didn't want to introduce the wallets just not to scare you for this, but what I realized is that as a developer in the software like Aragon or other implementations, what you're actually, when you do the test, for example, because that's what you're working right now, right? You're trying to simulate some of these things in a test. You don't need a wallet, software or hardware to create a transaction. There is actually a lot of tests that are creating transactions. They can sign them. So usually in a test, what you do is that you generate the private key using, or you can actually hard code the private key. We have some tests which have a hard coded private key, and then you can derive the public key from that, and then you can sign the transactions in the code, so you can actually simulate it. And so the idea that I had is possibly I don't think we have it at the moment, but it would be quite useful to have some kind of smoke test where we simulate this particular things that we just described, right? Like the two nodes, you basically need two nodes connected to each other. One of them is mining, one of them is not mining, and then transactions are going through to actually try to reconstruct this and to see whether these things, some of it is already in the test that you're looking at, right? Some of this machinery, but maybe what you're looking at is just one from the perspective of single node. But we could try to create a test with multiple nodes in it and just to play it around. Okay.
Okay.
So what's the time? Yeah, I think we probably had enough for today, I would say. Was it useful?
Oh yes, 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 it was.
Yeah, I just wanted to ask anybody else wanted to have any comments or questions or anything like this before we finish. As I said, I didn't have any specific topics for today, but I'm happy to hear any other things. Nope. Okay.
Come on, Tulio, wake up if you have something to do with my descriptions of the mining process.
Okay.
No, it was okay.
Okay, so yeah, thanks a lot for joining in today again. We will. I hope we're gonna we keep doing this. And again, we're still experimenting with the format because previously with the business hours, I had to spend quite a lot of time preparing. And it's sort of like I might still do these kind of things, but we also might want to do something like today, which was sort of ad hoc without preparation to see if it's useful. And any comments or any suggestions of any feedback about this privately or publicly, welcome. Okay, guys, so have a nice, if no more questions or comments, have a good rest of your day.